In this presentation, we look at some conceptual questions that we could use to examine the law of reflection. So this is a question that I would typically pose to a class, and I would provide sort of a picture. But we're just going to go through it in the PowerPoint. So there's a barrier that's placed in front of, but not touching a plane mirror, and we're going to see this on the next slide. The barrier is perpendicular to the mirror. Suppose you have a flashlight that projects a narrow beam of light. A target is placed successively at points A, B, and C on the left side of the barrier. For target locations A and B, indicate a location on the right side of the barrier where the flashlight could be placed in order to hit the target with the light. And for target C, determine the entire region on the right of the barrier in which the flashlight could be placed in order to hit the target. So here are our targets. And essentially we want to place like a laser pointer essentially over here. We want to be able to hit the mirror and then hit the targets over here. So if I wanted to hit target A, I have to have the law of reflection. So if I were to imagine having a normal line that's right at the barrier, I could have a ray of light that, if I work backwards, right, that light coming from A hits that surface and then comes over here. And so if I put the flashlight at this location, I would be able to hit A. If I want to hit B, it's a little trickier because of my barrier. I'd have to put the flashlight really close to the edge so that it could hit that point and then reflect off and hit point B. So essentially, if I had another point over here, let's say point D was over here, there's no place I could put my flashlight to be able to hit it because of the fact that the law of reflection has to be valid, and I've essentially reached my limit as far as being able to hit points on the left side when I place it at B. If I want to hit point C, I have a range of places that I can put, and I have some range that I could hit A as well, but I only showed one example. So if I want to hit point C, one of my ranges would be such that the law of reflection has to be valid so that it hits that surface, it passes just the one corner of the barrier, and then it hits point C. So I could definitely put my flashlight over here. And then the other place, I would have to just miss the other point of the barrier. Law of reflection would still have to be valid. And then I could hit over here. Whoops. So there's a range. Any place that I wanted to shine my light between those 2 points would allow me to hit point C over here because I would be missing the edges of the barrier, and the law of reflection would still be valid for both of those locations. And so essentially there's lots of locations in between where I could hit that mirror and still hit position C. So another question that I typically pose would be a picture where after class one day you find a sheet of paper on the floor with the following drawing on it. Evidently, a student was doing an experiment that used mirrors and a light source, but the student apparently forgot to indicate the location of the mirrors on the paper. On the diagram, indicate the location and orientation of the mirrors. So here is the picture that you find on the floor, and you want to determine where are there actually mirrors located. And so the very first thing you should realize is that any time that the light changes direction, there has to be a mirror present. And the other thing that has to be true is that the law of reflection has to be valid. So what I can do is I can look at my first location right here, and I can separate out the angle of incidence and the angle of reflection. So I can draw a line that is a bisector of these two angles, and that would make sure that the angle of incidence here is equal to the angle of reflection. So the first step is to draw in that bisector angle, that bisector that separates those angles into equal values. And then the mirror would have to be placed so that it's perpendicular to that bisector, and the reflective side has to be on the side where the light would be incident and then reflected. So that's what I can do for each of those different locations. So I could do the same thing for the second location where the light bends. There's my bisector, and then my mirror would have to be placed perpendicular. and then I have another one down below, and there's my bisector of those two, angle of incidence, angle of reflection, and then my mirror is located at that particular location. So that's a little activity where we could use sort of this idea of the law of reflection and answer more of a conceptual type of a question. The third question here is definitely more challenging, but it's something that I like to do just to sort of show how mirrors work. So in each of the cases that we're going to look at, you're going to see the two lines of sight to the image of an object that's in a plane mirror. In addition, you're told where the object is. For each case, determine whether this situation is possible. If so, draw the location and orientation of the mirror. You may want to draw the location of the mirror would need to be, and then decide if it's possible. So this is, I'm reading this question, and you don't have a picture to go by. So here's the picture, and this is what I have. I have the lines of sight for two eyes, and what they are seeing is an image location. So both of these eyes are seeing the image, and a ray of light is coming to their eyes along those lines, and here is where the object is located. So the first thing that we would want to do is realize that each eye sees the image along that straight line path, and so if we were to continue those lines from where the eyes are located, each of these eyes believes that the image is located at some location where those two rays of light would apparently meet over here. So the image is located where those two rays of light meet for each of those eyes, because each eye is seeing that image. Because we're dealing with a plane mirror, we know that the location of the object and the location of the image have to be the same distance away from the mirror. So I'd have to place a mirror halfway between the object and the image. So I would draw a straight line connecting the object and the image, and then I would determine the halfway point. So, it's hard to do this in a PowerPoint presentation, so I did kind of have to estimate it, but if you were using a ruler, you could measure the distance between the object and the image here along that straight line path and figure out where that halfway point is, and then you could put sort of a crosshair at that halfway point. So there's my halfway point. The mirror has to be perpendicular to the line that's connecting the object and the image, right? So I could then, and it has to be located at the halfway point. So I can now put my mirror in, and now where my mirror is located, my object is the same distance away from the mirror as the image is away from the mirror. And on top of that, if I imagine that rays of light are leaving the object, striking the surface, and reflecting off, then the law of reflection is valid. So I'm going to go back for a second. There we go. So here's my picture, and then if I look at this ray of light hitting that surface and reflecting off, if I draw a line that is perpendicular to the mirror, the law of reflection is valid for this eye at the top, and it's also valid for the eye on the bottom. So this mirror position is possible since both eyes are in front of the mirror and they can actually see that image. And the law of reflection holds true. So here's another picture, and we can go through the same process. We have two eyes. Here's our object. So the eyes see the image along the straight line path. So I follow those rays of light that the eye is apparently seeing, and where they meet is where the image is located. I know that the mirror has to be halfway between the object and the image, so I can draw a line connecting the object and the image. And then I can determine the halfway point. So I measure the distance between the object and the image, and I figure out where that halfway point is, and then I put crosshairs, a line that's parallel and a line that's perpendicular, and where those meet is where the is the halfway point. And that's where the mirror is going to have to be located. So the mirror has to be located halfway between the object and the image, and it has to be perpendicular to the line that's connecting the object and the image. So there we go. So now the object is the same distance from the mirror as the image is from the mirror, and they are, both perpendicular to that mirror location. So the problem here, of course, is that what the first eye here at the top is seeing, that eye is located in a place where it is in front of the mirror and it all makes sense, but the other eye is actually located behind the mirror, and that doesn't make sense. So this mirror position is not possible since one eye would have to be behind the mirror. So this picture actually doesn't make any sense, and the law of reflection here is not really working in terms of where that eye is located. So the eyes cannot be behind the mirror. So this one would be not possible.